All right, so in this video, we have a quadratic equation right here, and we want to find the equations of the tangent lines that pass through this point here. So the tangent lines pass through this point. So we always want to sketch this out to begin with to give us a good idea. So we have a quadratic equation that looks like this. It's a positive one, and we can tell that the y-intercept is +3, but I'm not going to actually label that value. And then I have this point here at 2, 3. So you can actually tell that this tangent line is going to be a horizontal tangent line, which means the slope is going to be 0, and then the y value is 3. So you can automatically tell with no calculations that one of the solutions, if there's more than one, is going to be y = 3. But again, we'll worry about that a bit later. Don't ever actually put this as a solution, but over here, there's a nice hint to tell whether our calculations will be correct at the end or not. Now, you have potentially multiple lines. For example, you could have a second tangent line that goes through this over here. So we have one tangent line here. We have one tangent line here. We want to find the equations of these tangent lines. We don't know how many tangent lines they're going to be, but we don't have to worry about the number of tangent lines. We just have to do the math, and the math will automatically tell us how many tangent lines we'll have that will pass through this point 2, 3. Sometimes you could have one, sometimes you could have two. There may be potentially 3, but I'm not 100% sure. But again, we don't have to worry about that because we can just do it from the calculations. So this point over here, you want to mark this point as some x and y coordinate, but don't use x and y, and also don't use a and b, because we use x and y for our regular equation and we use b for the y-intercept. So I'll just pick this point to be C and D. I don't use C and D for any other purpose. Okay, so I have my original equation over here. I know that to find the equation of this tangent line, I just have to derive this equation. So if I derive this equation, I'll get y prime equals to 4x. And then if I want to find the slope of this line here, let's specifically talk about just this one line. If I want to find the slope of this line, I need to sub the x value of this point in, which is c. So my slope of this line is just 4c. Next, I'm going to take a look at this line here, and I'm going to find my slope using your grade 10 formula, which is m equals y2 minus y1 over x2 minus x1. So it's just d minus 3 over c minus 2. Once I have these two formulas over here, I have two formulas. I can substitute them together to basically get a simpler solution. But the problem is I have one, two, three variables, but two equations, which means that I need to come up with a third equation. The third equation you can use is you can actually just sub in this point. This point is on the curve. You can sub it into the original equation. So that can be a third equation. So what I'm going to do is I'm going to sub in CD in this equation. So I'll get D equals 2 times c squared plus 3. So now I have three equations. I have three variables I can solve with substitution. I'm just going to replace this m over here with 4c. So I have 4c equals d minus 3 over c minus 2. I'll cross multiply this over. So 4c squared minus 8c equals d minus 3. And then I'll replace this d with this equation over here. So 4c squared minus 8c equals 2c squared plus 3 minus 3. Plus 3 and minus 3 just cancel each other out. So 4c squared minus 8c equals 2c squared. Bring it over to this side. 2c squared minus 8c equals 0. Common factor 2c, c minus 4 equals to 0. I have two solutions here, which means I have two equations, c equals to 0 and c equals to 4. So let's start with equation number 1. where c is equal to 0. Now c, remember, is just my x coordinate. So instead of writing it as c, I'm just going to write it as x equals to 0. X and c are the same thing in this first point. To find the y value, I'll just sub in the y value in my original equation, and I'll get y equals to 3. And this is the first scenario I was talking about here, this tangent line over here. Again, you don't need to draw it out accurately as I did, and in most cases you won't be able to, but you'll still get the right solution as long as you follow the same math. So the equation of this line is going to be y equals mx plus b. I know that to find the slope of this line, so now that I have this point 0, 3, you can just do y2 minus y1 over x2 minus x1. You'll get 0 over 2, which is just 0. So there's no slope here. So the equation is just y equals to b. And if I sub in the y value as 3, we can use either of these 2 points. So just get b equals to 3, and then your equation is y equals to 3. So like I explained here, without any calculation, and as we see, it matches a solution, which means I know all my calculations are like 99% correct. Let's do it for the second equation. Equation number 2, I know that the c value is 4, so the x value is 4. I can sub in the x value of 4 into the original equation, and I'll get 2 times 16 plus 3, which is 35. So now I'll go y equals mx plus b. I can find my slope by doing y2 minus y1 over x2 minus x1. So 35 minus 3 is 32, and 4 minus 2 is 2. So 32 divided by 2 is just 16. Again, you should probably write that down on paper, but I'm just doing it mentally. So y equals to 16x plus b. Then you can sub in either of these 2 points in. It doesn't matter which one you use. I'm just going to sub in 2, 3 over here. So 3 equals to 16 times 2 plus b. 3 equals to 32 plus b. b equals to negative 29. So my second equation is just y equals 16x minus 29. These are the 2 equations that are tangent lines to that curve and pass through the point 2, 3.